metals and nonmetals. First of all, what are metals? Metals are materials holding the characteristics of being shiny, hard, malleable, ductile, etc. Examples: gold, silver, aluminium, copper, iron, etc. Non-metals, substances which are soft and dull, non-lustrous, non-sonorous, non-ductile, non-malleable, and poor conductor of heat and electricity are called non-metals. Comparison of physical properties. Metals are generally solids. There is an exception of mercury, which is liquid at room temperature. Non-metals are generally liquids or gases in nature. Metals are malleable in nature, that is, they can be folded into thin sheets. Non-metals are non-malleable in nature. Metals are ductile. They can be converted into thin wires. Non-metals do not show this property. Metals are highly sonorous in nature. They produce a sound when struck by a substance. Generally, non-metals are non-sonorous in nature. Metals are good conductors of heat and electricity. Non-metals are not usually good conductors of heat and electricity. Metals are highly electropositive in nature. Non-metals are highly electronegative in nature. That means metals give their electron to the other atom and non-metals take electron from other atoms. Metals react with water, giving oxides. Non-metals do not react with water. Chemical properties of metals. On reacting with oxygen, metals give metal oxides. For example, sodium with oxygen gives Na2O. Non-metals also give non-metal oxides. Then what is the difference between them? Most of the metal oxides are basic in nature and most of the non-metal oxides are acidic in nature. Reaction with water. Metals on reacting with water gives metal hydroxides and release H2 gas with heat. Non-metals do not react with water. Dilute acids. Metals with acids give metal salts and release hydrogen gas. Example, magnesium with hydrochloric acid gives magnesium chloride and releases hydrogen gas. Non-metals do not react with acids to release H2 gas. Reason, non-metals cannot lose electrons. They can only take electrons. Reaction with salt solutions. When metals react with salt solution, more reactive metal will displace a less reactive metal from its salt solution. For example, here zinc displaces copper. When non-metals react with salt solution, more reactive non-metal will displace a less reactive non-metal from its salt solution. Reaction with chlorine. Metal on reacting with chlorine give metal chloride. Similarly, non-metals on reacting with chlorine give non-metal chlorides, but there is a covalent bond that is obtained. Reaction with hydrogen. Metals react with hydrogen to form metal hydride. Non-metals also react with hydrogen to form metal hydrides. Reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activities. A more reactive metal displaces a less reactive metal from its salt solution, as we have seen in the last slide as well. Here, zinc on reacting with H2SO4, that is sulfuric acid, gives ZnSO4 and H2. This reaction is the most popular reaction that we have seen, and it is one of the famous activities in which the brisk effervescence of hydrogen gas are formed. Ionic compounds. An ionic compound is a chemical compound composed of ions held together by electrostatic forces termed ionic bonding. The compound is neutral overall but consists of positively charged ions called cations and negatively charged ions called anions. So in this example, magnesium, which has two valent electrons, gives one electron to chlorine and another electron to another chlorine because chlorine has the valency of 1. They share the electrons and after that they form a bond of magnesium chloride, that is MgCl2. Since magnesium is giving 2 electrons, it acquires the 2 plus charge, and since chlorine atoms are taking 1 electron each, they acquire negative 1 charge. Properties of ionic compounds. Physical nature. Most of the ionic compounds are solid and hard due to strong force of attraction. Melting and boiling points. They have high melting and boiling points because it requires large amount of energy to break such strong bonds. Solubility. They are soluble in water and insoluble in other solvents. Conduction of electricity. They do not conduct electricity in solid state, but in molten state there is a possibility of conducting electricity. Occurrence of metals. So metals are extracted from their ores in which they have high concentration. Then there are 3 type of steps that we need depending on the type of reactivity of those metals. If metals are of high reactivity, we do the electrolysis of molten ore and from that we get the pure metal. If they are of medium reactivity and they again are divided into 2 parts like carbonate ores and sulfide ores. So for the carbonate ores, we do the process of calcination and for sulfide ores, we do the process of roasting. In both the processes, we get the product as the metal oxide. We do reduction action for that. We reduce the metal and we get the purified metal. Metals of least reactivity are mostly sulfide ores, which go through the process of roasting and then converted into metal and then purified. Key terms. What is a mineral? Mineral is a naturally occurring inorganic solid having definite chemical composition, crystalline structure and physical properties. Ore. Ores are those deposits on the earth crust which have those minerals. Gangue are the unwanted impurities like dust, soil, etc. Refining is the process of eliminating impurities from the metals in order to get pure metals. Calcination is the process to heat the ore at high temperature below the melting point in absence or in limited supply of air. Roasting is the process of heating the ore at high temperature below melting point in presence of air. Reduction is the process of taking away of oxygen from the compound, and displacement is the process of displacing cation from a compound. Important ores that must be remembered. Sodium is extracted from rock salt, aluminium from bauxite, iron from hematite, mercury from cinnabar, zinc from zinc blende, copper from copper glans, calcium from gypsum. Note, there can be more ores for a single mineral. Surface of some metals such as iron is corroded when they are exposed to moist air for a long period of time. This phenomenon is known as corrosion. Examples: rusting of iron, blackening of silver, and green coating on copper. What are the prevention methods of corrosion? Painting, oiling, greasing, galvanizing, chrome plating, anodizing, and making alloys. Fun facts. Sodium is a metal that can be cut using a knife. It is that much soft. Mercury is a metal which is liquid at room temperature. It is used in thermometers as well. Metals like gallium melt at body temperature. So if we put gallium in our hand, it will melt at that instant. Sodium and potassium are kept in kerosene oil to prevent catching fires. They easily catch fire with water or oxygen. Unlike other nonmetals, graphite and iodine have metallic luster or shine. So graphite and iodine are non-metals, but they have metallic pressure. Some metals like sodium or potassium have low melting point. Mercury and bromine is liquid at room temperature. Carbon, a non-metal, has a high melting point. Alkali metals have a low density. Lithium has specific gravity of 0.53, whereas iodine, a non-metal, has specific gravity of 4.9. All metals are not very hard. Lead is a metal, but it is very soft. Similarly, sodium. Diamond is a non-metal, which is the hardest substance we know. Non-metals like graphite and gas carbon are also good conductor of heat and electricity, which is not same for all non-metals. Some metals like bismuth and lead are poor conductors of electricity. All metals do not give hydrogen by reaction with acids. For example, copper, mercury, silver, gold, platinum, etc.